So it's basically where you place the text in your like your files. So for example, something that looks like this, and you could say like, for example, like my name is, and my age is like this, right? And so what you do is you replace the 0 with your name and the 1 with your age. That's called interpolation, right? And so you can like kind of interpolate that generically across all classes, right? So effectively, you can kind of think of an abstract class as have a bunch of this behavior that's very similar between these classes, but it's super like abstract, like it's not concrete. Like I can't create this send type. Like that doesn't make sense because it doesn't. It's missing parts, right? And the parts that it's missing are what we define as abstract methods. So in this case, it would be missing the actual send, right? So the actual like build transaction, for example, the actual and this has some arguments to it, maybe return some kind of transaction type, right? And then we also have maybe another one which is like populate variables, right? Which would take in like some kind of string and return the string that it's populated. So like replace all the variables in that string, given the transactions that it's previously processed. So you can like remember. And so that stuff is consistent across all, but like for example, the actual send itself, where it sends a transaction like this, maybe you take a transaction in, maybe you record what transactions, doesn't really matter. The way you actually define it, that's actually going to be abstract and it doesn't have an implementation, right? And so this method here is going to be reliant on your subclasses to go and implement it, right? So your subclasses are going to come along and let me sip my coffee. I haven't slept for like 48 hours, so I need coffee. So if I sound a bit tired or I'm bad of it, I'm sorry. I had assignment due last night that I did not get started on until very late. So I do not blame anyone who's who worked on their assignment very late, because I also worked on my assignment very, very late. So yeah, so it was interesting. So so I just saw something, but yes, so I lost my train of thought. So if I'm out of it, that's it. But yeah, so the idea is that you have this like transaction here, right? That's generic, it depends on whatever your kind of system is, right? And so this is actually what I do basically at my work. No, not really. But like I guess roughly this is like one of our systems, right? And so I actually worked on a new system the other week. That's this basically distributed system, right? Where we have a bunch of sending operations and each node can send independently. And then we have to reconcile those dispatches. And the problem is that we have like billions of records, right? And so you can't use just one big database. You have to use what we call a non-relational database, which is effectively just like a big array where every record really has no relation to the other records. And so it becomes very efficient if you know exactly what record you're looking for, but very inefficient if you don't, right? And so the whole idea is that when we're going to dispatch things, you won't have things like suppression, right? Like not sending you the same email 10 times in a row. And so we know what email we're looking for. We know like the user and we know the dates that we want to suppress for. So it becomes very easy for us to look those up. And so on, right? And so that's kind of what I want to spend today on. I don't know. Are people okay with that? Like with me just basically going through a bunch of design patterns like in real life, getting some real code that will be somewhat relevant to your project, like at some actual game code and stuff. If you prefer me to do anything else, just let me know. Because I presume that's going to be useful, but who knows. So to begin with, I'm actually just going to switch over my screens because it's going to be awkward if the chat keeps popping up on this one. So just let me stop sharing and bring it over. So I've got a Kahoot. Now there's not 9 people here. So we'll begin with that. And then we'll go over a bit more. But did that answer your question on abstract classes versus interfaces? So interfaces are kind of like when you just want to like implement one specific behavior, like for example, jumping or running. You won't really use it that much in the assignment, but you will use a little bit. Be careful about overusing it, but because it kind of like, I'll show you an example today. What I'll do is I'll show you one of the previous assignments projects. And I'll show you my UML, and we'll kind of walk through it It's a very big UML, but it'll have some design decisions in there, and we'll get about that. Anyway, and we'll show you some production code as well. And let's share. Okay, so screen 2 and Mike, maybe, I don't freaking know. There's also UNSW one. I don't know half this stuff. Okay, so this one just contains basically questions based on previous week as well as this week, because I want to see how much people remember from the previous week. There was basically nothing in it, so hopefully people haven't forgotten too much about it. And that deafens me every single time. So there's the thing. Just join along. We'll just do it for whatever minutes. I think it's useful because it means it just helps me know about what content I need to cover. It means we can go over the questions. And I inserted some funnier ones and gave more time than I did last time, so hopefully it should be good. By the way, for the project, I did create a video going through how to install it locally because originally there was only one way, which was to use the VM, but that wouldn't have worked on Mac anyway. And I was like, most people want to run it locally. So that video is, I think, on the announcement. So give that a go. I can also just go through it today. It's very, very easy to set up. But people will still have problems with it, which is why it's a video, right? Because it's like if you make one or two mistakes along the way, you'll find there's problems at the end. Okay, while that's going, let me talk about something. So the first thing that I want you to think about with the assignment, right, with the project that's coming up, is I know it seems like you're immediately jumping into the next thing, which is very much like a work life. But in reality, you got a bit of break, right? So how it works is that the first milestone is simply put just user stories. So there's really no code. We're not going to mark any code. I'll wait like 10 seconds, 20 seconds more. And so what that means is that it's up to you to decide on how much effort you're going to put in early to make your life easier later. And really trust me, like I've seen this probably course on maybe 3-4 times now. I've only tutored it twice now, but like, yeah, seen it run. And almost every time the people who start writing code, like week 1, are significantly less stressed. It's a very, very short time span to do a full project in, and it's very, very fulfilling to do it. And it feels great once you do it, but you will hate parts of it, right? And so if you start from day 1 and just start writing some code, just start like playing around, like literally the first part, the second milestone is there's no UI whatsoever. It's just the backend code. So don't even worry about making it look nice. Just like have something that like functionally works and write unit. I did. I'm back. Okay. I am not clue what happened. Am I back? Hopefully. Yeah, I would start it. Let me know if you can hear me. Yeah, okay, awesome. So all I was saying was make sure you start unit tests from day 1. I'm horrible with unit tests. I'm basically I still have to do like 20 unit tests at work for like all my PBIs that I just haven't done yet. I'm very bad at remembering to do them, which is very bad. You should do them. Because they make your life easy, because instead of just trusting your intelligence and hoping that you can write good code, which you probably won't be able to, because like no one can, and then finding out it doesn't work, and then like having to stress out because like people are like testing and going, this doesn't work, or like sometimes some code goes through production and breaks things. Luckily I've never had something like that bad, but you know, having to like fix things as people are testing them and stuff is not great. And so it's much better to like start early, and then you kind of, if you write your tests, you know what your code is going to look like. So if you write your tests, you can kind of understand how your code is going to piece together, and it kind of makes more sense than trying to like write the code first, if that makes sense. So you kind of like before you're like evading the lands, you're kind of like writing a strategic map, and you're kind of like, oh, how am I going to do this? How are my units going to interact with each other, and so on, right? Before you just jump straight into it. So to begin with, law of Demeter isn't a programming pattern, really, because it isn't like necessarily a pattern that you apply. It's just like a principle that you abide by. Law of Zeus is just funny because Zeus is Demeter's sister, Demeter's brother. I mean, let's be real, his Greek god's husband's probably somewhat correct at some point. And the correct answer was either strategy or state, as per the lectures. And when do you want to use strategy of inheritance? This one's a bit of a complicated one, so I'll be quiet. You think about it. And for those who don't understand some of these words, because they are slightly complicated, I mean, these ones are fine. A complicated, I guess, the hierarchy just meaning like layered hierarchy meaning like you got like a family tree that's very, very hot, like big, and there's like a lot of levels to it, and it's kind of interwoven, and it's kind of very complicated. And distinct disjoint basically means behaviors that are different from each other, and disjoint is kind of a different form of different. Like, these are kind of the same thing, but not really. So the difference between them is that distinct means that they're kind of like separate from each other, and disjoint means that their behaviors have no overlap, if that makes sense, right? So you could have two distinct behaviors that have overlap in their behaviors, but they're distinct because they're different, right? But you could also have two disjoint behaviors that have no overlap. Anyway, so the answers was either multiple actions that you could decide upon based on runtime logic, or distinct disjoint behaviors that together form the object. This is the better version of strategy pattern. I think strategy pattern is one of those patterns that people overuse way too much. Personally, there's a few of them that I like that. You'll find that if you Google a lot about strategy patterns and like OOP in general, some people have some very strong opinions, especially because in a lot of cases, patterns are just basically because the language doesn't support things, and so you kind of have to invent parts of the language rather than just having the language support it in the first place. Like today, if I show you some C# code, you'll see that getters and setters in C# are much nicer than Java, and like there's no such thing as a get method, right? It's just much easier to write them and so on, right? Because the language supports that. Anyway, and so this is slightly better, but this is also fine. I just want you to be careful about this for your project, because be careful about like window shopping for things when you go for looking for patterns. I see every year, and it's okay. It's just that this is probably one of your only chances that you really get to like go overboard with applying patterns. So when you're going overboard, make sure you don't go like overboard, right? Because in a lot of cases when we apply patterns, it's because we found a situation that's really, really bad, right? And so it's basically a fix, right? You're trying to fix something that's already bad. It's sometimes we don't always approach it from the good direction first, because sometimes that good direction is unknown or is very costly originally, and we don't know how long it will take to develop, or it just will require a lot more extra infrastructure. So sometimes we start from a simpler format that's perhaps less nice, and then we see how well the simple format works, then we can complicate it if need be. So for example here, which of the following doesn't apply to a state pattern? Now I do say doesn't, and I want to be a bit clarified here. I don't mean like it still could technically be a state pattern, but like it's not something that's necessarily a good state pattern. So think about it as if you represent this as a state pattern, is there another way you could represent it that's much less code, much simpler, and basically doesn't require a lot of extra layers? How many people have read the spec so far for the project? I presume none. a very, very long spec. It was much longer before. I think it was like 30 pages before. I got it. I was like to Matthew, I was like, we got to cut it down because if we don't cut it down, people, yeah, it's now down to I think 15. But I was like, if we don't cut it down, people won't be able to finish it. So it's not intended necessarily for everyone to finish it. Like the marking scheme's gonna be very generous in terms of like completion. The idea is just to kind of give this very, very kind of broad depth, so you can kind of choose whatever part of the game you like more, right? But in saying that, it's much simpler now, and there's a lot less complexity. So I actually think it's very plausible for most people to finish it. Like I sat down and wrote a version of it in about I don't know, I think it's probably 16 hours max. Me and Matthew, everyone. So that was probably about what we'd expect most people to be at. They play a few more hours than 16. Anyway, so the answer here is that I would say a floor switch is probably the worst one out of all of these in terms of a state pattern. So animation system, thank goodness no one said this one. This one's probably the best case. The only good case I can always think of for a state pattern. The problems with state patterns, they're very, very complicated to write and they're very, very complicated to maintain, like seriously complicated. So when you're building one, you really have to kind of like have a honestly good reason for implementing it, and an animation system is a really, 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 really good reason. The key thing about state patterns is people always get confused between them and strategy patterns because they both decide logic based on conditions. The difference is that a strategy pattern updates over time and typically has multiple behaviors together, right? So it's accumulation of multiple behaviors rather than just a single behavior, where a state pattern has defined transitions between states. So every state transitions to the next state. And I'll show an example today with a job system in a game where a character can go and pick up some items, then he's in a certain state, then he goes and drops those items and he's in a different state, right? And there's a few other examples I'll show today as well. So floor switch is the worst one here because it's basically just a Boolean, right? You're either toggled by the boulder or you're not toggled. So honestly, I see this all the time for the previous assignment, which was like a dungeon crawler. What would happen is people would have a boulder on a floor switch and they would have it as like a Boolean on and off, which is great. And then some people would use it as a straight state pattern. But the thing is to actually use it as a state pattern, all they would have is they would have like a public, I think it was like get is toggled method on the state that would return a Boolean. So all they would do is they basically just wrote their own Boolean, where one of the states would always return true and the other state would always return false. So they like wrote, I don't know, for like 40, 50 lines of code to just do a true and false. And that's just, it's not really necessarily that useful. And finally, this one is, I get, I think I spelled this wrong, who knows. This one, I get why that's kind of confusing. But a video player definitely is a good case for state pattern because if you think about it, it has some very complicated behavior in terms of how buffering works. So for example, when you're in the video, you're initially in this kind of buffering state. And then from there, you kind of can transition to a play state or pause state. You can go back and go forward. And the actual buffering has to change dependent on your position, right? And so it's not necessarily a strategy pattern because the strategy is always the same in terms of like how much buffering to do, how much to take, and like maybe even technically, I guess you could even have a strategy behind it, but typically you wouldn't. But typically the buffering will have kind of some kind of like state system, right? Like for example, if you go back 4 minutes, right, you may have already saved that parts of that video, so you could just grab it, right? But also if you go back 4 minutes, then that could be argued as a state transition in terms of like you could have a series of states every minute that you record a certain amount of audio to let you go back and forward, right? It doesn't really matter. Anyway, I do kind of get people saying that, but I would probably argue it's fine. Which one of my pets, Kita? Because I wanted to show my pets because they're adorable. This one's Chippy, and this one's Amelia. Making you make the hardest decision in your life. And the answer is they're both cuter. I do think he's definitely cuter. Like his little paws, this is cute. Anyway, very adorable. Let's go next. Which one of the following is a great use case of strategy? So this one's what it's kind of been talking about a lot. And often. I even at the very beginning of the talk, I talked about like the dispatcher and stuff like that. Okay, so the answer is basically everything but the following one. Because determining the AI based on the type is technically a strategy pattern. I would really argue it's template pattern, but people argue it's strategy. And then having the AI become smarter as you play is definitely a strategy, right? You know, that especially if the strategy isn't just like it isn't just like stats. You know, they deal more damage. If they actually change how they play, you know, at the beginning they make more mistakes, and then as you get better and better, they make less and less mistakes, right? And then the only one that isn't is this one because the keyword is statically, right? It's defined once and won't change. Okay. When is a good time to use the design pattern? Okay. Yeah. So, yeah. So I would argue that, especially with layer stuff, design patterns should be one of those things that you should be very careful about because people overuse them way too much. But if you've isolated a problem and you think hard about the problem and not just the symptoms, then definitely they can come useful. Like I see all the time, like for example, I'm sure some of you have said that where you show me, or if you look at the forums, right? Typically someone will be like, oh, here's my problem. I think I should do this. And it's like, well, you've identified there's a problem. You've identified what the problem is, but you haven't necessarily identified what the fix is, because what you're trying to do is you're trying to fix the symptoms of that problem, right? Just going straight to the root cause. So if you have a gut feeling that something's wrong, then typically what your feel is wrong, right? So don't try to like wrap around it. Don't try to like add layers of abstraction and go, okay, well, you know, for example, okay, I want to inherit a data member and have a virtual data member that's shared between two classes. Okay, so I have to have getters and setters that I override in the subclasses so that I can do that. Then I always have to use getters and setters so that like I can have this virtual data member kind of simulated, right? And the problem there is the fact that you're trying to get a virtual data member simulated, right? That's the problem, right? Not necessarily that it's hard to express, right? Or that you should try to do all this craziness to try to express it. Instead, you should try to just remove that and try to make it better. Anyway, last question. What can you do with an abstract class? I think a few of these are correct. They must be. Looking at them now. I did this like 20 minutes ago, but I don't remember what I did because I'm working on like 30% of my brain power. Oops, sorry, I alt-tabbed. I expected it to go to the other window, not this one. I'll wait for it to finish. Then we can go into it. So we're going to just basically look at some code and talk about some real design patterns, then go from there. So what you can do with abstract class is define non-ab methods is the big one. You can also define abstract methods, right? You can class a subclass to it. You can't inherit from multiple classes on a construct. Okay, awesome. So we can see who wins. This is the most important part. 4 asterisks. Honestly, after a hard week, I feel like that. That's mood. And hello. I thought hello was gonna win. No, ASDF. Oh yeah. That was a lot of my childhood. I don't know. Literally remembering all the little things about that show, YouTube series, whatever. Okay, so to begin, just kind of give you a rough overview of what this thing was. So it was a game that was built by about 100 people plus. I gosh, if I know the exact number, I guess I can find out in a second if I actually click it properly. Here we go. It had, we even see how many contributors? 110 people contribute. So I was one of the admins on it. I came somewhat late to the party. As you can see, I wrote way too much freaking code for this, writing 40,000 lines. But the most thing I was impressed by is the fact that I deleted almost as many lines as I added, right? And this is the one things that you should be aiming for your project when you get to milestone 3. Is when you're starting to clean things up, try to remove as many lines as you can. Anyway, there's still a pull request from, I think, almost 2 years ago now, from the 3rd of March, which is a much better day than today. That's and I looked through this morning because I haven't touched this thing in like months, right? And it's talking about many things about it. And one of my favorite things is this comment right at the end. I say, like, literally more than a year ago, I say at least another week, 2 weeks before completion, right? I was very naive. I basically just we got really busy, right? Anyway, so I'll talk a bit about this and well, the system works because this is a very good idea for what a observer system and strategy and all that stuff. Really, the main one I want to talk about is a state pattern. So we're going to toss open some code here, and so the best thing about Thor's code is it was built by open source people, which means a lot of it's written very simply. It's a game. I can show you the game, I guess. It's just a base building game, right? You can see here, this is it. So you could like build things, move things around, and like create tiles, and like you'd have these little men who'd walk around and like pick things up and move them around and so on. And they each had like job systems and job queues, and there was just pathfinding, and there's like temperature and atmosphere as well. No. This was many years ago. This was not uni. There's too many people to make it uni. It really was. It started off as just a tutorial to basically teach people how to make complicated code. It had like Lua scripting as well. It had like entire sub-scripting language in it. Like, oh gosh, and it had modding, I think, as well. It had so much stuff. Like, I can't even find some. Like this stuff is so old. I don't remember where anything is anymore. Maybe here. Yeah. Okay. Yeah. So this was one of the things I worked on was this entire system. I'll talk about this a bit later. Because it's kind of cool. And this uses a lot of listeners and stuff. Again, this code was written many years ago when I was probably 16, maybe 17. So keep in mind the code is not necessarily always good. And the last code wasn't written by me. This was written by only me and Kent. Kent did most of the code, I think, here. Anyway, so the idea of this system is that you have entities that move around, right? And so these entities are like little humans and little gear. And what they have to do is they have to do jobs, right? But we also don't want them to just like stand still when they're not doing anything. So we want them to have like idle states where they kind of just like wander around aimlessly like this, right? Where they can kind of, for example, have a total time spent and they kind of just like walk around until this time is spent, right? So it's kind of just like a chill time. You can add, for example, leisure into this. You know, let's say they've got needs, right? There was a basic needs system that was discussed but never implemented, right? So maybe I've got a need to go to just relax for a bit, like go on the couch and sit, right? Leisure. And so once that need is met, I'm happy and I can go, right? But before that need's met, I want to walk around and kind of enjoy life a bit. And so the key thing about these states is that it's extremely state pattern, right? Like this is all like it's got it in its name, but literally everything about this system is state pattern. So for example, one of the best things is this is a game engine thing. So what we have is we have an update that ticks every frame. So every state gets an update every single frame. And this measures the time since the previous frame, right? You guys don't have to worry about this. Real time is very difficult and annoying, but effectively this delta time is kind of like times and seconds since the last operation was performed. So you can do physics and things like that. Typically you don't want to do physics with delta times. You want to do it with like fixed steps. And the reason why is because calculations for like friction stuff get very complicated when your time step isn't fixed and when it's going up and down. And so typically it's much nicer if it's constant. And so the idea of this, right, is that you have like an update that ticks every frame. And so for example, what they do is they look at the action. Right? So they grab, and there's this big like stack of actions, right, because they've got like a job queue. And so in this case, he's grabbed his whole action. And he's looking at it and going, well, what did I do? And he's going, okay, I've got to dump my material because I just picked some stuff up. So what it's going to do is it's going to change its character's state, now put itself in a dump state. So that means the next time it ticks, it's going to follow a dump state and go and try to find a place to dump. So the actual behavior of the character depends upon its state. And this is the really important thing about state patterns, right? Is that the behavior of the entity changes to follow the state. Right? The state pattern isn't just some function, some interface function you call every frame, right? It actually is intrinsic to the character and physically changes the way the character behaves. In this case, for example, he wants to find some material, maybe to go and haul it, to put it somewhere, or maybe to go and build with it. There's so many reasons why he could. So he goes and he looks through all the behaviors, all the inventories to find one. He finds the closest path, right, which uses the best thing about starting like this is that we have multiple different path algorithms, and we use the strategy pattern to choose the best one, right? And so, for example, in this case, most likely, if you're in a really, in a confined space, right, we're going to use something called Dijkstra's algorithm, right, which is basically just a spiral. It just kind of like spirals around you in like kind of a circular way. Like it's kind of like BFS, right? First search, where you just kind of bubble out like a spider web. And so it's very good with confined spaces because typically you don't actually know what path you're going to take because you may have to go around little corners and like there's little walls and so on, right? Whereas if you're in a very open space, you can kind of just like shoot for where you want to go and just go in like a straight line and then just make some small maneuvers where you need to. And in cases like that, we use something called A star, right? And there's another one too called, I think it's called J star or Job star, that's useful when you have like basically like a ship, right, where there's multiple levels and you want to like go up and down those levels, and so you kind of have a three-dimensional map. And so, but it's not really three-dimensional because like the way you go up and down is by like ladders and stuff. And so to represent things like that, we represent it a different way. And so the idea is that you have a strategy pattern, right? And it determines the best strategy to take dependent upon where the character is, who's around it, and so on, right? And it comes into everything. For example, let's say a character is moving towards a position, but there's always someone in the way, or let's say someone builds something in the way. What happens? We have to adjust that pathfinding algorithm, right? So the pathfinding algorithm itself becomes dynamic, right? So anyway, so you can see he looks through his material, he can pick up material, he can move states and so on, right? And so they've all got states, and there's this entire kind of job system that's built around talking about abandoning things and so on. And this sits on top of a very fancy what we call a priority queue, which is effectively so if you've done 2521, you kind of made a priority queue. It's built a bit differently for efficiency, but the ideas are still the same, right? And so that's kind of a cool kind of consequence of like the state pattern, right? Is that you're able to express these systems that are quite hard. Like it would be very hard to express behavior where you can kind of decide whether or not you can actually reach a job, for example, or whether or not you should even move there. Like, how do you decide whether or not you can no longer move to a job? Like, that's what would you do, right? So if I'm moving towards a job and I can no longer move there, in a state system, I just move my character into this kind of like maybe into an idle state to wait 10 seconds. Maybe it comes available. Or maybe I try to like move him into a state in a looking state. And so once he's back in a looking state, he'll look for a path, and if he can find it, he'll find it. If he can't find a path, then maybe he enters another idle state. And then in that idle state, he goes, okay, now I want to find a job. So then he enters a job seeking state or whatever. Like obviously there's a lot of states, right? So you can simplify it. But the idea is that since each state is very simple in terms of what it behaves, you kind of get this emergent behavior where your character kind of transitions back and forward, almost like a dance between the states, right? And you can express these very complicated behaviors very simply as a sequence of steps, right? And so for your project, state patterns are actually quite cool. And so effectively your project is kind of like Civilization, if you know what that is. If you don't know what it is, it's basically just kind of like a game where you are kind of going to control a series of territories or cities, and over time you're going to take over other people's cities or try to build buildings, try to gather wealth, try to invade or try to defend, just try to expand your influence, right? And you win based on conditions like that. For example, you win on wealth, I believe. I think there's also a goal based on like getting every territory, and so the idea of you as a player, right, is that when you're viewing how the AI will behave to the players, like that's staked in a nutshell. Right? Like, you can't express a complicated AI. And very simply, you don't have to, right? The very simple AI is you don't have to. You can just do like a series of steps. We give it to you, like do this, then do this, then do this, then do this. Right? It's very simple, right? Originally had a bit of logic to it, but I was like, no, 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 no. Just make it like step by step. Like there's no decisions other than just like if this is this, do this. If this is this, do this, right? Because you have so much to do, there's no point for it, right? And so when you want to do complicated AI, if you want to do that as an extension, you get marks for extensions. One of the things you could do would be a state pattern, an aggressive state, a passive state, right? And your state patterns don't have to be explicit. That you can have this kind of like gray period, right? You can have like a transition, right? Where you are like somewhat aggressive and somewhat not aggressive, right? And so you can have states that are composed of multiple sub-states, right? That like talk about like, are you aggressive diplomatically? Are you aggressive in terms of how you build? Are you aggressive in terms of like actual aggression, like attacking people, right? And so you can kind of like complicate your character's behavior and your AI's behavior that way. Now, I'm trying not to talk about patterns that you guys don't know yet too much. I will talk a bit about a few things, but one of the first things I want to talk about is the event system. So in any game, having a good event system is so important. It's like the most important thing you can like immediately you need to like sit down and go, we need an event system in this game, right? The reason why I say that as I cannot find a decent event system in this system. There is a good one example here. This one's okay. I just prefer a different version of it. I'll find it. So the point of an event system is to basically have like a series of subscribable actions, right? So when something occurs, you want to do an operation. So rather than having to check that every single frame, you basically have a list of functions or observable actions that you are going to execute upon the action actually executing, upon that event triggering. So for example, let me show you actually a good example, and I'll show you it in here. So let's say I've got this furniture. I have this action here, this trigger. Whenever I update my door, I want to do something. For example, I wanted to change how open it is. I want to set its animation state. Again, state pattern, I guess. When I update an airlock, it's just the exact same thing as a door. And so this is ugly, very ugly code, but it's very easy for people who can't code to write. So we use it. And so you can kind of have all these complicated behavior that is based upon actions, right? So when something occurs, you want to do something. And so, for example, if I look here, you know what? There's one really good example. Is this the one I'm looking for? No. So this is kind of pretty much close. So this is good enough. I'm happy with showing this off. So what you have is you have updatables, right? So for example, in this system, we have multiple updatables that occur timescales, right? So you may want something to occur every second, every 10 seconds, every 20 seconds, every 50 seconds, and so on, right? And so you can represent that by saying what timescale you want to represent the system in, right? And you can also speed up and slow down the game for that reason, right? And those things occur less. There was one really good thing. Oh wait, maybe is this it? Oh yeah, okay, this is what I'm talking about. Okay, so I have not seen this code in like 2 years. So for example, adding events, there's two ways you can do this. You can have this like main event system, right, which is like a whole separate class. It's like a singleton, which is a very fancy word for basically saying you can only create it once, right? So a singleton is very useful in game design. Maybe I'll show you an example of that today. Why don't I show you an example of that today with audio? I'll show that off in a second. And so you could have this like one big instance that only ever exists once, and it basically kind of controls all your events. So everything goes through it, right? That's okay, but it kind of just becomes really big, really fast, and it doesn't really have a responsibility. It's got everything, right? It's managing its responsibility is managing events. but it's managing all events, right? And that's a lot of responsibility in terms of like it's managing every event's every frame, every event's on creation ticks, and so on. And it becomes inconvenient. For example, when you want an event to trigger on when a unit gets destroyed, it's very easy just to chuck the event on the unit. So once the unit gets destroyed, the unit can trigger its own event, rather than having to like look through and go, okay, does the unit have any subscriptions to this event? Like, you don't want things outside the class trying to like trigger things for that class, if that makes sense. And so, for example, this furniture object here, when we want to do an action, when we actually create the furniture, let's say we place down an oven, we want the oven to turn on, we could subscribe an event to this created here to basically say, hey, when this occurs, I want to do something. And Java, sadly, it's not particularly easy to do it. And C# is very nice. In C#, I can just do something like this. I created this plus or equal to some kind of method which takes a furniture object, F, and does something with it, right? That's all I basically have to write. I can do whatever I want in here, right? And the plus or equals will figure out, oh, okay, I want to include this as an object. I can also just use equals to override everything and so on. Freaking love it. If you want to learn like a really nice language, C#, it's so easy to use. And so that's like how kind of events work. In Java, you have to do it yourself. It's pretty easy still. All you're basically going to do is have a private list of interfaces. Right? Each interface, there's a few ways you can do it. You don't necessarily always have to do interfaces. For example, there's something called by consumers. And a by consumer, for example, takes two actions and consumes them. So for example, you could take an int and an int, right? It has to be integer in Java because Java doesn't deal with that correctly. And so in this case, you basically have a function that takes two integers and consumes them, right? And there's other options too to have more complicated types, right? You could also just use an interface, right? It's up to you. So the idea is interfaces can get a bit messy if you have like 50 of them though. So maybe use by consumers and consumers and so on. And if you care about where to find them all, just Google Java functional. Sorry if I'm speaking fast. I just don't really want to go too much overboard in terms of time. You can see them all here. So consumers, by consumers, functions which return results, binary operators that operate on the same type. There's all this stuff here. I would recommend using them as much as you can and only going away from this when you have more than the types that are specified here. It's up to you. Anyway, so that's basically it. It's pretty cool because it basically lets you define kind of these actions that you can subscribe to, right? And when you learn about observables next week, what you'll find is that an observable is kind of like a really bad event, right? Which is one of the reasons why we don't typically use observables outside of one very specific case, which is when we're binding UI to backend, right? And so what an observable basically is I'm going to observe this object, and whenever this object changes, you're going to tell me about it, right? But that's just an event, right? But it's really generic, which means it's kind of not that useful in the generic case. And typically you only ever have one case where it's used. For example, like you'd have an observable that triggers every time the entity is modified, but not necessarily when it's deleted, right? And that's not always necessarily useful because like, are you going to care about every modification? No, not really. And it's typically having this more generic event system is better. But it's completely up to you, right? How you want to design this stuff, right? And so when you build your kind of front end and your back end, you're going to be using things called properties, right? Like integer property and float property and Boolean property. And what these properties allow you to do is like to bind things together. And what binding is basically saying these two things are kind of coupled, right? Like literally, right? And so every time, like those really annoying couples that you see walking around with their hands always together, right? And like, a train go through the middle of them and they would still be holding hands, right? And so like, regardless of what's going to happen, right? They're going to always be coupled. And so when you have a binding, especially a bidirectional binding, anytime one thing happens to one of them, it will also happen to the other. So what it means is that you can have like some text, right, that shows how much money you have and never have to update that text. You just bind the text to your money and it's done, right? You can walk away and be happy. And so observables are great for things like that, right? When you want to basically do an action every time it updates, and you can kind of wrap around in this property. And they're not really great for the use for the typical case, and they're actually deprecated in Java. Like a lot of the observable classes are deprecated in Java because they're just not very useful, and typically the way people build them, it's a bunch of problems. Okay, so there's a bunch of other things in here that I could talk about that maybe I'll talk about in future weeks, such as like localization, which is a really interesting problem. Like how do you localize languages? I believe this thing supports like 20 different languages because we had so many different contributors. And so at the end of the day, it was effectively like you have to like swap in and out text and try to do things like, for example, the way text is formatted in one language is going to be different than the other. Like how do you handle plurals, for example? For example, in English, sheep is both a plural and a singular term, right? You have one sheep, you have two sheep. Whereas in maybe, I don't know, say Chinese, maybe it isn't, right? Or Japanese, it isn't. I'm not aware of either. But there's definitely like languages, especially like Spanish languages and stuff, like Portuguese or whatever, where a lot of the singular and terms and the plural terms can get very confusing, right? Especially when you get into things like German, where it gets even harder, right? So handling these cases is important. Anyway, so localization is kind of an interesting problem, but it's not really that relevant for your assignment. But kind of the main takeaway I want you to think about this is think about like the characters and stuff, especially with the state patterns and so on. Yeah, linguistics. So think about the state patterns and think about like, can you use it in your assignment? For example, when you look at it, you'll have like buildings, and these buildings will transition between like levels. Could each level be a state? Like, is there enough different between each state? Think about like the strategy, for example, in terms of how your allies will behave. For example, some of them have special abilities. There's this pattern that you'll learn about later on called the deck pattern, which is really, really nice. The decorator pattern basically lets you apply buffs or debuffs, which are like good or bad things to units, and you can kind of like wrap those units in like another class that's basically the exact same thing as they were originally, but slightly changing a few things, right? And so you kind of have these layers of abstraction where you kind of wrap over and you change small things, small behaviors. And actually, you know what? There's a case I can show about that. So that's a bad example. So I do not remember why I put any of this stuff, but this code is so old. It's probably in UI. Yes, this is the last thing I'll show. So this was one of my big things I worked on when I was very new to this project, I think. I built this entire UI system that was like programmable. So the idea was that you could like program every aspect of it. So like even the settings menu, for example. And so you can see here, this is like the settings menu. You can define like generic elements that like wrap on top of other elements. And so it's kind of in some ways like the decorator pattern, where you kind of say, okay, generic toggle is the exact same thing as this other toggle, but you're just going to change these two behaviors, right? You kind of, I guess in some ways it's almost like an adapter, right? So you're saying it adapts to the same behavior as this other type, just with these things changed, right? And so you see that with a few of the more complicated behaviors. I don't necessarily know if I've got an example here that I can find easily. There's a lot of things, for example, like this. This is a observer. So we're observing when a value changes, when we're doing behavior based upon that. Again, I feel that C# here is easy enough for you to understand. Let me know if you're confused by anything. This basically just looks like Java, right? There's not much different between it. There's a few really nice things about it, but other than that, it's pretty much just Java. But yeah, okay, this is a really good example. So localization combo box is just a combo box, right? But the only difference is that it's just going to adapt the interface of what a combo box is to a language dropdown. And so the reason why I say adapt is because it actually has to change quite a bit of behavior. Because it actually has to like add an extra component that actually handles the actual updating of the dropdown, because languages can update as the game executes, like what language you have installed, how we show those languages, and for example, like the order of them. They can even like update as you go, like if you add new languages to the game as you're running it. And so we have to add this new component and then like adapt how the combo box works to this component, right? And so for example, you can see here, we actually adapt the entire value change and adapt behavior of how this value change works, right, to a specific component here, right? And so you can see here where we select current languages and stuff, we adapt how the cancel settings work. So now we can kind of go into our localization table how to adjust to it. Not necessarily an amazing example of adaptive pattern, but you can kind of in some ways see how it's used, especially with things like get value, right? We're adapting what the value here means. So the value for language means something very different to what the value means for the combo box, right? So the value for the combo box is like an index, right? And so we have to kind of like map it between these two states and kind of understand that like as you reload, what language you're going to have installed in what order could change, and so we have to adjust for that. And there's other things too, like quality combo boxes, but this is more of a typical kind of inheritance thing, right? Where you're just like changing a few things, and you're not necessarily adjusting things too much. Anyway, so I think it's pretty cool. There's a bunch of stuff here that I kind of like. I think, as if anything, things change over time. Like, as I could show you, like the components and stuff. It's just a lot of UI code, and this is all dynamically inserted. And one of the awesome things that you can do with a lot of these things as you write code and stuff, and in terms of as you're going to kind of get better expressing some of these problems, is that you can write stuff that automatically will write itself. And so, for example, all these methods here automatically will insert functions, or like it basically at runtime will do something called reflection. It will look at all these functions here at runtime and figure out what the function arguments are, and then allow you to call them from the game command line. There's a command line in the game that pops down, and you can like run these, and we don't have to put them anywhere, right? Just by the fact that we have the name here, the fact that it's static, and the fact that it has arguments, it will automatically fill this in, right? And will automatically figure out what the types are, how to express those types, and how to like basically read input. Right? I don't really know what I would say that pattern would be. I guess it's in some ways. I'm sure there is a pattern for it. It's what's it called? Is it called the command pattern? I think it's literally called the command pattern. Anyway, it doesn't really matter. At the end of the day, I think most of this code just came naturally rather than explicitly. Anyway, so this is kind of cool. It's a very big nostalgia trip for me to take it. It's animation state and stuff. There's one more thing I wanted to show off, which is I think just to make you feel disappointed a little bit in Java, which is how easy getters and setters are to write in this language. So this is all you need to do to write a getter and setter in C#. Is you can just say I want to get and I want a private setter, and that's it. And the best part about this is that you can make these custom. So for example, let's say I wanted to make a getter. Type prop tab. I mean, you could also do that, right? But I could write a getter here, for example, character names. And all this getter is going to do is have a custom getter when I'm going to say return characters dot am I going to be nice? Yes, okay. And then I can use something called link, which is just like streams. The only difference between, link is amazing. Link is one of the best things that can ever exist. It's like streams on steroids. Yeah. The best part about it is it applies to everything without you having to say .stream, and it's reasonably fast. So I can do a select here, and I can select on, for example, I presume there's a name. There is a name. There's also a get name, which is a bad style in this, but anyway. And so I can, for example, return all the characters that match the name. I could return IEnumerable here if I wanted to be fancy, or I could just convert this back to a list, right? And whoever's doing .collect with the generator list, if it was like, I mean, I try not to. Like last year, I dissed a bit on Java. Like every time we would find a feature, I'd be like, if only they implemented generics, right? Java is a fine language. It's definitely okay. And you can even do setters, for example. I don't really know what a define setter here is, but you would have this value type here with this value is like the setter value. I don't need a setter. I can just do a getter. But I think it's still a fine language. It just is kind of a product of its time, right? It's kind of like when you have like maybe a grandfather that says some things that are perhaps put it a bit lightly, a bit inappropriate these days. And you're like, well, he's just a product of his time, right? And you're like, things will change in the future and they get better, right, over time. Like Java's getting better and better and better, but there's definitely things that are bad about it. And you'll find those things, and it's okay, right? It's okay to be angry at languages for things, right? It's also really good languages in a lot of regards, right? It's not necessarily all bad. There's a lot of really good things it does, and it's very, very popular, which helps, right? So I think Java can definitely get you a job, but so can most languages, so it doesn't matter. Anyway, I think that's everything. I don't really want to talk about anything else. I think nothing else here really matters. I think I mentioned I was going to talk about singletons. I guess I can briefly do that if I can find the audio class, because that's the only good example we have here that's necessarily should be singleton. Probably controllers? Yes. No. Maybe. Who knows? Sound control, that's probably it. Is this a singleton? No. This is one of the things that could have been singleton. The game control probably is singleton. Anyway, it doesn't really matter. Global variables, but spicy, yeah. So yeah, this is a singleton. Okay, so the idea of a singleton is, how about I write one in Java rather than write one in C#? Because C# makes them a little bit nicer, but not by much. And I think Java actually typically handles them a little bit better, actually, in terms of discouraging them in some cases. So for example, if we want to create a singleton, let's say we have an audio manager, right? Now my audio manager is a very small chance I'll ever want to have an audio manager more than once in my game, right? I probably only ever want to have one thing that manages audio, right? I mean, you want to have multiple instances of audio, like, for example, you want like a television that like plays audio and you can kind of hear like the sound go across the room as it reverbs around the walls. And then you also want, like, for example, like glass shattering, right? And so maybe you'd have like little audio, I don't remember the words for it. There's little, what's it like? I guess. Sometimes they call them actors, right? Little audio actors. I don't think it's correct. But anyway, have like little like actions that occur as the glass splatters everywhere, right? But at the end of the day, you're gonna have something that controls everything, and how loud something is, when it will occur, what sound it grabs from. Maybe you also have like a streaming manager that handles actual streaming of the audio, because that's actually a pretty difficult problem. Because it turns out that audio, when you're streaming a lot of it, kind of becomes a bit of a nightmare to make sure that you're not like throttling your system as you're just like sending like megabytes of audio through your caches and everything. And it doesn't sound like a lot, but it can kind of hurt, especially with most people having the actual audio cards on their CPUs. Right, so we have this audio manager here. I don't press Command S. The whole point of a singleton is saying, okay, I only ever want this to exist once, ever. So the first thing we always do is we only define one constructor. I mean, you can define multiple, but typically only one. And we make it private. What this means is that we can never construct this object. Effectively, it's abstract. It's not really, because we can still construct it inside the class, but for every other class outside the object, they can't construct it. The next step is to basically, you can also make this package. Sometimes we will make this package. The example thing is, if we look at the game manager, one of the things this game controller will have has a bunch of other things inside of it, and the game controller itself is in singleton. Right, so this is a singleton, and then it has a bunch of other things inside of it, which makes them effectively singletons. There's got less inside of it because we split it out, but the main menu controller is also a singleton that has stuff inside of it, and so on, right? The scene controller and world controller and so on. My ears are now ringing. I probably need to get some water after this. Anyway, so we have this audio manager here, right, that manages itself and it's going to create it. So the next thing we're going to do is create a static variable that basically represents this audio manager. Now we're also going to make this private. Now you'll see why in a second. And we'll just call this instance. I like doing it like this. Habit. I like putting all my private statics as underscores. Typically, I put a lot of my private variables with an underscore at the front. I do not know why. It's probably just from a bit of a mixture of using C++ and C# and everything. It doesn't really matter how you do things, right? And the next step is to basically define a method to get this. So we're going to define a static method that returns an audio manager, and we're going to call it getInstance. Now we're going to be good Java people and use proper casing. And that's it, right? So the first step is we're going to check whether or not the instance actually exists, right? This is static, so we can access if the instance exists. Well, if it doesn't exist, we're going to create it. And if it exists, we're just going to return it, right? And so it basically just looks like this. And so the idea is that you now have a way to construct an object at runtime if you need to. Like sometimes, obviously, you can just do like this. And you go, wow, look, I can construct it. But like, let's be real, a lot of the time, this has to bind to something that's already running. Like our audio manager definitely has to, or sound manager, whatever. Like for example, it has to bound to an actual world to register events. For example, like when things click and so on. I guess this could be registered afterwards, but there's other things that do too. For example, when it creates a sound system, like as you can see here, it has to grab it from the audio manager. And the audio manager has to allocate the sound system when it initializes, as you can see here. And this initialized behavior occurs at runtime. Right? So we could wrap this in a singleton, and suddenly now we can actually initialize this object, right, in a nice way. And so the idea here is that it only ever creates the object once. If it's already existent, it will just return it. So you only ever have one of these objects around, but you also have like a very generic interface of using it. And the way it's typically done in other languages like C# and stuff that have like proper properties is that you can just kind of write this in a very simplistic way. It's a bit different with Unity because Unity kind of has a very different concept of an instance, but the rough way of how to do it is you would have something like this. And what you do is you'd have a get method that's defined like this. You have a, for a private static main menu controller. Put instance. And when you have this main instance here, you can have a get method, right? I think you can even write it like, there's so many different ways you can write stuff nowadays. All right, so it doesn't really matter. You can write like this, and you could go, hey, if the instance is true, then we can return the instance. Or well, if it equals no, I guess you can set it. Doesn't really matter, right? Oh, it equals a new. Cannot spell. Instance equals a new main menu controller, right? Return instance, right? And so suddenly now you have this very nice way of writing these getters, right? Once the code actually decides it's going to compile. And so you have this very nice way of writing, or it's kind of expressing these problems, right? Where you don't have to call in functions. You can just say dot instance and then you instantly access it, right? All right. I'm too advanced apparently. Whatever you want to call the word is. I'm using features that don't currently exist in this version. Anyway, it doesn't matter. So with Java and stuff, it's still quite nice. And so I definitely recommend thinking about whether or not you need any singletons. Try not to overuse them because it's one of the things that kind of sucks every year is when you see people who have like 10 singletons because it will suck for when you unit test them. Singletons are a huge pain to unit test. So if you're gonna basically have a singleton, make sure it's something that like you really only ever want one of, i.e. like an audio manager, if you're ever doing audio, because you're not going to be unit testing that most likely, because it's probably going to be an extension. Anyway, I think that's everything. So it's going to be basically just marking labs today. So honestly, I'm probably just going to set up some a simple quiet room and then maybe a room if we want to collaborate, and then the rest will just be marking. Does anyone need to get going quickly? Because I presume with how much marking we'll be doing. How do enums go? I can show you a case of how enums can go. It's up to you basically though. Here, make sure that I'm not showing any kind of a sign because I did have someone's diagram up the other day on this. Yeah, I do have someone's diagram up on the here. That's good. Okay. I gosh, if I know if this is the right one. Sure. Discard changes. Yeah, authorize. You can authorize. Okay. I might do that. That logs in. Rooms. one. Enums are pretty great too, especially in Java actually. Java enums are brilliant. Compared to like a lot of other languages, they actually kind of got them correctly, right? Somewhat surprising. Come on, sign in. Yep, you can sign in. Good. Okay. Yes, I can trust Draw.io. And let's see if it's going to take too long to load. And still showing the skydiving elevator bottom as it's loading. Okay, it's going to probably take a couple of seconds to load. It's a very big diagram. Like a very, very, very big diagram. Like it's still loading kind of big diagram. Like this is a very big diagram. Yeah. This was my final project. Yours is probably going to be a bit bigger than this because there's a few more classes and stuff you guys have to do. But this was the old one. Let me show you an enum. So an enum, there's two ways you can do enums. This is the way I did them. I don't really like this way anymore, but you can feel free to do this if you want. You effectively just have to give it like enum at the top, just like interfaces, list a bunch of enums. If you have any properties like get ID, list it. And then you can use them as compositional relationships. Feel free though to just actually do this as an association. An association here is 100% okay. And the reason why it's 100% okay is because an enum is effectively, in most cases, unless you have a very complicated enum that has like a lot of extra storage, is basically just an integer, right? In this case, it literally is, right? And so when I'm storing this, it's not really an association arrow. Like this is more what I was thinking. In reality, I'm just kind of associating this kind of priority integer with this priority inside this updatable, right? Especially in this case where the updatable is just an interface, it's not actually holding it. Like we don't really care that much about your UML in terms of like the exact specifics. It's just kind of like, is it generally correct? No, you don't. You should really only have like has and stuff when it's not obvious. So for example, this one here is kind of important. So I defined my own observable type, which I actually may release for people because it's a really nice observable type because it's just a generic. So if you want to make an observable like integer, right, you just say observable and then just chuck the integer inside of it and it handles like listening, the updating, like it handles everything inside of it really nicely. And so I use that for my observable positions in my system. And it's just a little bit easier than having to like rewrite this everywhere. Anyway, so in this case, I had a binding, and I stated specifically that it was binding this T here to this position 3D, right? Because this is generic, which you learn about later. So don't worry about generics right now. But it's just kind of like a list, right? Where you have like a list of integers or a list of strings or whatever, right? Okay. That's it. Okay. So there's nothing else really. We'll talk about everything else later. I can show you this because this time is very different. And you'll see maybe we'll even show off the app and stuff so you can get some ideas in terms of like how much depth do you have to go through the UI. Though mine's probably not a good example because I kind of just had fun with it by the end because we were doing a proper semester, so we had a lot more time. So this is quiet. And then finally we also have just like I'm just going collaborative just in case you want to like chill with people. So before we jump into anything, is there anything that people want